should not get confused with 8085 processor. So that is why when you are studying the 8085 and 86 both, it is better that you compare and study, so that those instructions and these instructions, they should not get mixed up. One thing you should always remember when you are studying 8086 is the data bus and address bus will be 16-bit. So that is why you can make out the difference between 8086 and 8085. So now we will start with the addressing modes. The topics are very easy. Only thing is you should not get confused with them. So I will share my screen now. So hope you are able to see. The first page is as usual blurred only. I don't know why it is coming like that. So the definition of the addressing modes, if you will see the definition, I don't know if you can recollect something. So the different ways how you can specify the data in an instruction, that is known as addressing mode. So in an instruction, you will have two things. One is the operation code and another one will be the operand. So generally the data on which the instruction is to be performed will be specified. Either you can give directly the data in the instruction, or you can give it in the register, or you can give it in the memory location. So three different ways are there in which the data in an instruction can be specified. Now, just now I said in an instruction you will have two parts. One is the operation code. What operation is to be performed on the data which is given in the instruction. So the operation is known as operation code. In short, you will call it as opcode. So hope you can recollect some things. Now since you have done the lab also, you will be familiar with this now, what I am talking. Now, the data can be specified in three different ways, I told. Either you can give the data directly, or you can give it in the register, that is your general purpose registers, or you can give it in a memory location. So if you are giving it in a memory location, we have seen for 8086, you are having 1 megabyte of memory locations. So from where you have to take the data, that particular address of that location. Yes, I said earlier also, if it is a 100 pages notebook and you are writing your notes in that notebook, you will give page numbers 1, 2, 3, and one particular topic which you are searching, you will go by the page number, or more better example is the index of your textbook. So you will look for the topic and you will see the page number and you will go there. So see here also the data, if it is given in a memory location, then that location will have an address. So since here your address bus is 20 bits, you will have that particular address, and from that address you will be able to track the data on which the operation is to be performed. So depending upon the different ways in which the data can be specified in an instruction, here the addressing modes are categorized in the three different ways. One is register addressing mode, another is immediate addressing mode, and memory addressing mode. So just now I said no, the data can be given directly in the instruction, or it can be given in a register, or it can be given in a memory location. So these three different ways are given the labels: register addressing mode, immediate addressing mode, and memory addressing mode. So register addressing mode, you can understand very easily that the data or the operand is given in the register only, in the register addressing mode. So you can better understand this particular addressing mode by seeing the example instructions. So whenever an answer is coming on the addressing mode, then it is better if you can give at least one or two examples on the particular addressing mode. That it means seeing the examples which you have given also, people can understand that you are having a good knowledge about the addressing mode of the of that particular processor. So now registers in the 8086 you are having 1 byte or 2 byte, since they are 16 bits. So you can have the lower register or you can have the upper register. So, but one thing you have to remember in the register addressing mode is their size should be same. Now, size should be same means your source and destination register should be of the same size. Now, see the example, move CL comma DL. So, CL and DL both are lower byte registers. So, 16 byte means it is CX you will mention. So in this case, now move CL comma DL. So move is the operation which is to be performed on the data in CL and DL. Now CL is your destination, DL is your source. So that is why here it will be move CL comma DL means whatever data is present in the DL register, it should be copied into the CL register. So syntax will be operation code, destination, source. So first register in the instruction will be destination. The second one will be source. This is same in 8085 also. There also. Now one more here you can remember that CL and DL both are only 1 byte registers. Then next instruction when you see move AX comma BX. So AX and BX both are 16 bits register. AX is 16-bit register, BX is also 16-bit register. That is why the size of the registers from where the data transfer is going to take place to which it will be taking place, they should be of the same size. So here also now you might have understood that move AX comma BX means whatever data is there in BX will be copied into the 16-bit register AX. Now not only the general purpose register, you can move the contents in the stack register also. So DS, this was the segment, memory segment, DS, data segment. If you remember, you had some memory segment registers. So in that, DS is your data segment. CS was your code segment. ES was extra segment. SS was stack segment. So not only in the registers AX, BX, CX, DX, you can have the data transfer from the stack register, index register, and the segment registers also. So I have mentioned there, you can also see that the register can be anything, AX, BX, CX, DX, SP and BP. These are SP is stack pointer and BP is base pointer. SI and DI are your index registers. SI is your source index register. DI is your destination index register. Rest of them, that is CS, DS, ES, SS, these are the segment registers. So memory segment which is there in your block diagram. So there you can see those CS, DS, ES and SS. So data transfer can take place through that also. So in the example move DS comma AX, you are having move the contents of AX 16-bit register to your DS's data segment register. So this one is very easy for you, register addressing mode. The only thing is you should take care that the data transfer takes place between equal size registers. So that one point you should remember when you are doing the register addressing mode. Next one is immediate addressing. The same register addressing, immediate addressing is also there in 8085 processor also. Now immediate addressing, you know very well, the data is given in the instruction itself. The source, when you say opcode, comma destination, comma source, the source will have the data directly. Now again in this also, the data which is given and where it is to be copied should be of same size. So the two examples which are mentioned, you can very easily understand. Move CL comma 15H means 15H is your 8-bit data. It is copied into a 8-bit register which is CL. Move CL comma 15H. Similarly, if you see the next instruction, move BX comma 1000H. 1000H is your 16-bit instruction, it is being copied into your 16-bit register, which is BX. So like this, you should take care of the number of bits of the data getting transferred from source to destination. Now, these two are very simple ways of addressing. Now, next one, memory addressing mode. So I said when you are using the memory locations to store the data, then you will take into consideration memory addressing modes. Now, in this memory addressing mode, you are having 6 different ways of how to specify the operand. So now this little careful you have to be in the memory addressing mode is how the memory is being used for the data transfer. Now in this also direct addressing mode. This you have come across in 8085 also. Direct addressing mode. Because memory is involved, we are giving it a label, it is memory addressing mode. Now direct addressing mode, if you see the definition is the address of operand is specified in the instruction. Directly the address is there in the instruction itself. Now one thing which you have to see is whenever we are specifying the operand as a memory location, it is given in the square bracket. Now if you see the instruction move CL comma 1000H, it means the content of 1000H location will be copied to CL, means the memory address is 1000. In that, what data is there? That data 1000H is not copied, but the data which is present in the location 1000H will be copied in your CL register, which is, so the data here is 1000H, the data is only 8 bits or 1 byte, which is copied into a 8-bit register CL. Now, data can be 1 byte or it can be 2 bytes because you are having a data bus which is of 16 bits. Now, next instruction you see 1000H is the address and it is to be copied into CX register. Now, in this, what will happen? You have to be very careful here at this point. Whatever data is there at 1000H location is copied into lower byte of the register. It will be copied into CL register. And your 1001 memory address location data is copied into CH register. So directly what address is given, that data lower byte is copied into lower register, higher byte is copied into higher register. So this one point you have to be little careful when you are writing also. So as I mentioned there, CL and CH will get data from 1000H and 1001H respectively. Now next one is register indirect addressing. Register indirect means in the register what address is there, in that address location what data is there, that will be copied into your destination register. Now move CL and in the bracket the register is written. Since the address will be 16-bit, you are using BX register. So it is total 16-bit address is present in the register BX. And at that address location, what data is there, that will be copied to CL. Vice versa is also possible. So that is why the next instruction says that whatever data is present in CL register, that is your source, will be copied into a location whose address is given in the base pointer or the stack register. I told SP, stack pointer, and base pointer. These two are called stack registers. So in that stack register, address is given. The data in CL will be copied in the address location whose address is given in the stack register BP. So this point you can note there. And then next is your indexed addressing mode. Indexed addressing mode, you see, you are using index registers here. So that is why it is indexed addressing mode. Effective address of operand is the content of either source index or destination index registers. Now, index register is also 16-bit in width. So that is why whatever address is there in that index register, the data in that location is copied in AL, and index register content +1 will be copied into AH register. Since here only point which is to be noted is you are using index registers. So that is why it is indexed addressing mode. So if you see what I have written after the instruction, that contents of address location given in SI is copied in AL, SI +1 address locations content are copied into AH. So by this you can, since we are having only two index registers, SI and DI, only those can be used for indexed addressing mode. So all the time till now in all the three cases, we were giving the address of memory location. Address either you are giving directly or you are giving in a register. According to that, the label of that particular addressing mode is written. So by now, I think you must have understood that how these addressing modes are given the name also and how it is taking place. So little you have to practice all these things to reproduce again in the exam. Now next is register relative addressing mode. So this was not there in your 8085, register relative. So now see here, this is an improvement over your 8085. The operand address will be given by memory pointer plus 8 bits or 16 bits displacement. So in the example, only 4 bits are added. Now register relative means memory pointer here is BX. BX register will have the address of the memory location. To that, you are still adding another 4. You can like this add either 8 bits or 16 bits also. And after adding whatever value you will get, from that location, the data will be picked up and it will be copied in the CL register as per this example instruction which is given there. So it is register relative. Relative means you are adding some more bits in that. Now, next one is your base index. The operand address will be given by base register plus index register. So in this also, your base register is your general purpose register BX, and index register either it can be SI or DI. So the whatever content is there in the base register and the index register, those two addresses will be added, and that resultant address from that point the data will be copied into CL. So base index is like this. Then relative base index means again you can add, there is a provision to add 8 bits or 16 bits displacement. So this is something similar to your register relative, but here it is relative to your base index. So whenever you are saying relative, there is a provision to add something like 4, 8 or 16. So this is how the different addressing modes exist. So there are variety of addressing modes in 8086 processor. So with this, the addressing modes are over. Now next we have to see about the instruction set. So this will be very easy again. So all these labels, data transfer, arithmetic, logic, program control, string manipulation, processor control, they may look familiar to you. These are the different types of instruction set. Now in this, don't confuse this instruction set labels with your addressing modes. So the first addressing mode, that is register addressing mode, when you see, I said there, you can take it as an example to write for your data transfer, but when it comes to addressing mode, you call it as register addressing mode. So in the register addressing mode, it is a data transfer type of instruction. The type of instruction is data transfer, but the addressing mode is register addressing. So in the exam also, generally it happens that students get confused between addressing mode and the instruction type of the instruction. So you have to practice this also little, so that you can distinguish between what is an addressing mode and what is the type of instruction. So since having done the practical lab, I think you will have a clarity on this also. So this group of instructions, that is data transfer, arithmetic, logic, these are same as you see in your 8085 processor and 8086 processor. The Except that the way you denote the registers are different in both the cases. So here, see now, although I am giving you the different types of instruction which are there in the data transfer, but when you are writing in the exam, they may ask you that explain few data transfer type of instructions in either 8085 or 8086. So depending upon that, you have to choose which you remember or which is easy for you, and then write those instructions as an example for that particular instruction set. Now, it is possible that they may ask you to write or discuss the total instruction set, or they may ask you to explain only the data transfer type of instructions. So depending upon the question, then you have to answer the question which is being asked. So now the easiest one in the data transfer type is the move instruction. In this you will see there are different types of instructions. Whether you are moving the data to register or memory location or to input port, or from the input port or to the output port. So data will be taken inside from the input port and it will be given out into the output port. So that is how it is possible. Now, in this particular example, that is the move instruction, move destination comma source, which I was telling in your earlier cases also. So as you can see, it transfers the data from one register or memory location to other register or memory location. And direct loading of segment register is not allowed. This particular point you have to remember when you are discussing about data transfer. So segment registers cannot be loaded directly. I have given one example, move ds comma 5000h. That is not a valid instruction. Or if you are using also, the program when you are executing, it will give you an error. That is what will happen. So segment registers cannot be loaded directly. This much you have to remember. Otherwise, the general purpose registers, you can load them directly. So I have given you an example where 5000H can be directly written into AX register. Here 5000H is a data, whereas in the next example, that is move AX, when 5000H is in rectangular brackets means that it is the address of a memory location, and the data which is present in that address location will be copied. Now here when you can see to the right hand side, I have written AX and there is an arrow pointing towards AX, and then in the rectangular brackets I have written 5001 and 5000. It means that whatever data is present in 5000H memory location, address location 5000H, will be copied into your um, lower byte register, that is AL, and then 5001 will be copied into your AH register, the higher order register. So that is what it means by writing the memory location address in the rectangular brackets and showing the arrow pointing towards AX. That is how you have to understand. And in the next instruction, you can see that move AX comma BX. BX is the source register and AX is your destination register. So it will copy the contents from BL to AL and BH to AH. That is how it will move the contents from one register location to another register location. So in this, the first one is immediate addressing mode. Next one is the direct memory addressing mode. And then the next example is register addressing mode. So you see, there are different addressing modes within the data transfer type of instruction. So like this, you can have for any one particular instruction different ways in which you can specify the operand, either in the directly in the instruction or in the register or in the memory location. So it is not necessary for you to mention that this is that type of instruction. Simply if you can write the instruction and explain what work it is doing correctly without confusing, that also is enough to answer the question which comes for you. Then next is exchange instruction in this. This was also there in your 8085. So simply it will exchange the contents of source and destination. That is what it does. Now in this also one point which is to be remembered is exchange of contents of two memory locations is not possible. So exchange cannot be done among the memory location contents. It can be done between the registers. So in this also the examples are given. You can exchange between the contents of memory location and register or between the two registers, but not between two memory locations. Like exchange AX comma BX means it is between two register pairs, but it cannot be done between two memory locations. One memory location and one register is okay. It can be done. Then I said you can also data transfer type of instructions are also connected with the input port and the output port. So that in instruction and out instruction, these are the only two instructions which are used when you are talking in terms of input output port. But here the syntax is little different when compared to your 8085 processor. Here input the port means it is used to read an input port. So one thing you can have to remember is whatever you type on the keyboard, the processor is going to read it, and whatever appears as a result on the output port, the processor will be writing onto the output port. So that is why you say read from an input port, write onto an output port. Now, again here you have to take care of the size of the locations. AL and AX are allowed destination for 8-bit and 16-bit operations. So it is one of the register is accumulator. That is what it means. 8-bit port address is specified directly. 16-bit port address is specified by DX pointer. So in this, in AL comma 03 means 03 data will be written into your AL register, and DX is your 16-bit register, and from there the data is taken into AX register here. Now again same output to the port. It is used to write data to an output port. So we have to give the port address. See, output devices means you can have a monitor, or you can have a printer, or you can have a fax machine. On the fax machine also a print will come out, a paper. So these are all the output ports. So to which port it should go, that port will have an address. So that is why you have to specify the address of the port. So it is used to write the data to an output port. So out 03H, AL, whatever data is present in the AL register will be written onto the output port whose address is 03H. That is what it means. So I think there is no confusion. Input also, you can either have a mouse or a keyboard, which we all are very familiar with. So whether the data is coming from a keyboard or it is coming from a mouse. So keyboard will have one port address and mouse will have another port address. That you can give it by the instructions in. Similarly, writing onto the output port is given by the instruction out. So this is very simple about your data transfer type of instructions. Then next is your arithmetic instructions. So we are familiar that 8085 does addition and subtraction. But for multiplication and division, we are not having any instructions in 8085. Multiplication you are doing by repeated addition, and division you are doing by repeated subtraction there. So, but in this, since it is an advanced version of 8085, you are also having multiplication and division. Apart from these two, you are also having ASCII decimal adjust instruction. Now, ASCII decimal adjust instruction in 8085 was DAA. So that is your ASCII decimal adjust. Here also you are having that decimal adjust DAA instruction. So here one more interesting point will come, which you will see little later. Now, syntax again is add destination comma source. Now, in this arithmetic instructions, you can simply add the contents of destination and source, or you can add it with carry also. So, add destination comma source means the source can be a direct data, or it can be a data in a memory, or it can be a something data from a memory location. So these are the different ways in which the data source data will be given and the destination data can be. Now here one more point which is shown by a star mark is memory to memory addition is invalid. And another one more point which is to be remembered is the result of the arithmetic operations will be always stored in the destination. This point is also same in the case of 8085 processor. The result is always stored in the destination. The result of arithmetic and logical operation. So since we did not come to the point of logical operation till the arithmetic operation, you can remember that the result is stored in the destination itself. Now, what are the different arithmetic instructions which are possible is you can have add with carry, then you can also have increment, decrement, subtraction with borrow. Now, when you are doing subtraction, you have to remember that the source operand from the subtraction is done, like the source operand is subtracted from the destination operand and the result is stored in the destination operand. So just as the result of addition is stored in the destination, the result of subtraction is also stored in the destination itself. So both are similar, that is addition, this is subtraction. So you can remember in that way. Only precaution is memory to memory addition is not valid. It will not work out. Even if you are doing means it will show some syntax error, it will say. Now next is subtraction with borrow. So again same type of notation SBB. It will indicate that subtraction is done with borrow. So it is not SUBB, it is SBB, subtraction with borrow. Now here it is AX comma BX. So you can see on the right side very clearly it is written that AX minus BX minus carry. Because it is with borrow, it has to do the subtraction. That is why minus CF is done. CF is your carry flag. So carry flag and borrow will do the same work. Next is your among the arithmetic instruction, you are having CMP, that is compare destination comma source. So this compare instruction is there in 8085 also. So see there, point which is to be noticed here is when you are doing comparison, then the status of the flags are going to change. So destination operand is greater than the source operand means the carry flag is 0. If it is less than, then carry flag is 1. And if both of them are same, then 0 flag will become equal to 1. So this is one important point which is to be noted when you are discussing about the arithmetic instructions. So many new things for you to learn today. Then I told ASCII conversion is also taking place. ASCII decimal adjust instruction is also within your arithmetic instructions. So ASCII conversion means decimal adjust accumulator. This is also there in 8085. And if you remember, you have to use this decimal adjust accumulator instruction or DAA instruction only after the add instruction. Because see, when you are doing programming, you will take hexadecimal number system only. You will do all the programming with your hexadecimal number system. Now, if you want to convert the hexadecimal result into your decimal, then you have to, after add instruction, you have to use DAA. Means the sum which is in hexadecimal number system will now appear for you in the BCD number system, or BCD is your binary coded decimal or your decimal number system. Now next is this is new in case of 8086. How it is new, you see, the DAA is for addition and DAS is for subtraction. So just as DAA, you have to use after you have used add instruction. Similarly, DAS is to be used after using subtract instruction. Now, when you say, I have shown it in the example also, you can see there that subtract AL comma BL means it will do BL is subtracted from AL minus BL, and then after getting the result is stored in your decimal adjust DAS. The result will be stored in your BCD number system after using the instruction DAS. So this is how it is when you are doing the subtraction of the data. Now after DAS, we said addition, subtraction, multiplication, division, all these functions are being performed with your 8086 processor. So what is the syntax for the multiplication of the numbers? So here to be noted is it can multiply either 8 bits or 16 bit. 8 bit data with the content of AL or AX. So if it is 8 bit, then it is to be multiplied with the content of accumulator AL, or if it is a word means more than 1 byte, 2 bytes can also form the word. So hence it is written that byte/word that with the contents of AL or AX. So if it is a byte, then another one more data will be in AL, and if it is a word, then it will be in AX. I told you already, 2 bytes or more than 2 byte, you will call it as a word which is stored in your AX register. So I hope there is no confusion in what I am telling. Is it okay?
Yes, ma'am.
And you are able to follow the byte, word, by the representation of the register itself. You should be able to make out whether it is a byte or whether it is a word. Now, I have given 2 examples here which will clearly show whether it is a byte or a word. Since you are familiar with your registers, whether it is 1 byte or 2 byte register, depending upon that, you can follow this instruction also. MUL BH is only 1 byte. So where is the other data? See, for multiplication, you need 2 data. You will say A into B or X into Y. So one data is in the register which is specified in the instruction. Another data will be in your accumulator register AX. Now since here BH is only 1 byte, the other 1 byte data will be in AL. Point to be noted here. Then multiply CX means, see here, another data is present in AX, accumulator AX. So AX into CX, when you multiply, you are getting it, the result is in the AX register. And if the result is more than 16 bits, it will go into the DX register. That is why in this instruction, DX is to AX is written. The more than 16 bits will go into the DX register. Similarly, now divide instruction. Now in this divide instruction, whenever you are doing the division, again A by B you will say. A by B means it will have quotient and sometimes it will also have remainder. Now where is the quotient stored? Where is the remainder stored? So this is what you have to know when you are using DIV instructions. So example is very clear for you. You can see there, divide BL. So where is the another 1 byte data? It is there in your AX. Now this AX divided by BL, why did I give that? Because AX is having a word 2 bytes and BL is only 1 byte. So a word is divided by a byte. See, as long as I will say 8 divided by 2. So 8 is single digit, 2 is single digit. But if I say 16 divided by 2, means you have to imagine that 16 is your now more than 1 byte. Or it is a 2-digit number which is being divided by 1-digit number. So this division, you have to be very clear whether a word is divided by a byte or double words are divided by a single word. When I say 16 divided by 2, it is 2 digits. 16. It is divided by a single digit. Similarly here, word is divided by byte or double word is divided by a word again. So how it will be when you are dividing a word by a byte and you are dividing double word by a word. So double word you see, dx is to ax. It is given like this. Dx will have one set of word and ax will have another set of word. And the result again you see, result can be more than one word. So 2 bytes or more than 2 bytes, we call it as a word. I told this point earlier also. So double word is divided by word in the second example. And in the first example, you have to see that quotient is stored in AX, remainder is stored in DX. Similarly, in this DIV BX, the quotient is stored in AX and the remainder is stored in dx. So in both the cases, quotient is stored in accumulator, remainder is stored in dx, some other register. So this is how your arithmetic instructions you have to discuss. Sometimes it is possible they may ask you, write about the multiplication and division instructions of 8086 processor. Then what you will do? You have to only write how the multiplication instruction will be and how the division instruction will be, with giving these examples which you are having. So I think in your textbook also similar examples are there, because some topics is from your textbook only. So
Ma'am, good afternoon, ma'am.
Chepan, yes.
Ma'am, 2 bytes is equal to more than 1 word, ma'am.
2 bytes is 1 word, not more than 1 word.
2 bytes is equal to 1 word.
1 word.
More than 1 word means, ma'am? More than 1 word means?
More than 2 bytes you have to say.
Okay.
That
More
will
than
become 2 or more than 2 will form a word. So double word means it can be more than 16 bits. You can write in your notebook, 8 bits is 1 byte.
Okay, ma'am.
2 bytes is word. 2 bytes
is
word.
1 word.
Yes. More than 2 bytes is it can be 1 word, or you can, if there are 3 bytes, then you can make it 2 words. First word will have 2 bytes, the next word will have 1 byte and then followed by zeros.
Okay. 3 bytes means 2 words.
Yes, yes.
Okay.
But generally what they will do, word means lower byte, higher byte. Okay. Are you understanding? Lower byte, higher byte. So if only 1 byte is present in the second word, you can always put zeros.
Okay.
If
higher
that is
byte means that one sum, madam.
Higher byte means
one sum, ma'am. Lower byte
zero,
means
zero. No. See, now you are having AX register, is it not? AX register. If you see the block diagram, AX will be written as AHAL.
Okay, ma'am.
AH is your higher byte.
Okay, ma'am.
AL is your lower byte.
Hmm.
So now your AX and BX, if you take, it means it will become 2 words. AX is 1 word, BX is another word. Okay. So now in the division, see here in the division, always numerator will be more than the denominator, is it not?
Yes, ma'am.
So numerator can be, that is why here how to say which is larger, they will tell in terms of words. So that is why when you say double word by word means numerator is double word. Okay. And denominator is a single word here. Okay. Similarly, when you say div bl, I wrote there word by byte means numerator is a word, 2 bytes, and denominator is single byte. Okay, ma'am. Clear, ma'am. Next one is logical instructions. So see there, again I am repeating, if you cannot write everything, so if a question is coming like discuss the arithmetic of instructions of 8086 processor means 2-3 though you have to discuss, 2-3 instructions you have to discuss. If you are not able to write the complete list, so if you can see multiplication and division, multiplication also will be easier only. Division little you have to remember all these things, how to represent. See, what we understand and what we write there, they should be similar, no? What I am explaining and what is written there, that should go on the same line. Then only you can put your ideas properly in the answer. So always write the answer in such a way which you know very well. Don't go for complicated things unless you don't know properly. Now next is logical instructions. Now this you know very well. In this, no, some special instructions are included in your logical instructions. So logical operations like and, or, not, XOR are there. That is there in your 8085 also. And then addition to this, there are shift and rotate operations. So most of the time I am seeing they will ask, explain the rotate operations. Now, rotate operations, when you are writing, rotate left, rotate right, that left and right directions should be proper when you are discussing about the rotate operations. So in the 8085, I discussed this point in the class, I remember. You have to be very careful. In the instruction, if you are saying right, the figure also should be towards right only. Don't get confused between the figure and what you are writing there. So this point you have to be very careful when you are reading and writing in the exam. Because while correcting, if the figure is giving a wrong indication, means you will not get marks. That itself means that the person doesn't know how the instruction works. So now in this, see the although I have written their general syntax, logical operation means whether it is and, or, not, XOR. And then this is also got destination and source. So I think okay, it is not discussed by any example. Since it was easy only, I thought I will not put that. One minute, in your textbook, they have given the examples just as we discussed for your data transfer and arithmetic operations. They have given example for each one of them. So you can go through that. When you are writing the answer, it is needed because you cannot write like this. Did I miss something?
No, ma'am, in our textbook also they didn't give any example of rotate left, rotate right.
And it is there in 8085. I remember I told you.
Yeah, ma'am. In
Okay, don't bother about that. In the logical operations, you write the operation like it is and, means you have to use A and D. If you use ADD, it will become add. Add will go to your arithmetic instruction, it will go. So I am seeing sometimes people will get confused between add and. So and you have to use in the logical only. While writing, you have to be little careful about this. So I have given here only a general representation, but actually the what is the syntax for and, it is A and D, or it is OR. So like this, you give two examples for it. Since it is easy, I did not mention there. So in the textbook, it is given very nicely. Same way you can discuss about that. Now, next one is a bit by bit shifting is possible, and rotate operations. So rotate operations mean bit by bit shifting only is your rotation operation. Now in this rotation operation, they have simple only rotate is there, or it is rotate through carry. So for that, there are for simple rotate, it is you can see the textbook. RCR is rotate left through carry byte or word, and ROL is simply rotate left. Then rotate right is also ROR. If it is through carry, it is RCL, rotate left through carry.
Ma'am,
Byte
in the
or
textbook,
yes.
RCR is given rotate left through
Yes,
carry byte.
that is printing mistake is there. You correct it as rotate right.
Okay.
RCR is rotate right only. I also saw that point. It is rotate right only. There is a printing mistake there. So in this rotate, simply the byte or through carry, those two things are there. If you see 8085, their figures also are there. You will get a clarity on this. Now, since you will be discussing the logical operations with AND or not XOR, they are all easy. You can write the instruction giving it some example 1 or 2 and discuss. Then if you write in addition to these above instructions, it is also possible to shift bit by bit using the rotate operations. You can explain like that also. And then apart from rotating operations, you are also having arithmetic shift left byte or word, arithmetic shift right byte or word, and then logic shift right byte or word, and logic shift left byte or word. So simply as I wrote, you can also write like that only, and then stop the discussion. And then there is within the logical operation, there is also one test byte or word also is there. So I thought discussing each of these will become too big, and that is why I also did not discuss. I was also following your material only. If you want the discussion on this, I can give you. That is not a problem. Now next one is this program controller branch instructions. Branch instructions, whatever you have in 8085, they are all same here also. Conditional jump and unconditional jump. These are same here also. Now in this also you can write simply like this and also stop the discussion with that. Now unconditional jump is given as JMP. Where it has to jump? It has to jump to the location which is given by the label. So if you have used ascending order and then picking the largest number in that labels you have given, so that same label you will write there. Jump label. Label means it is only way to jump to that particular point or particular address. So in notebook also, if page is not enough, you will write, please turn over to page number so and so. You will continue on that page. So label is something like that. Now jump unconditional is simply jump and label, but conditional jump will have like JC, JNC, JZ followed by the label. JC, JNC. So if you are having still doubt on this, you can see some program where these instructions are used. So you will get an idea that what that label address was. Now similar to your conditional jump, you will have call also, call instructions and return instructions. These are also followed by the label. Then apart from the call, jump and return, you are also having push and pop. So push and pop are only two instructions which are used with your stack registers. Pushing onto the stack and popping out of the stack, we call it. So for this also, it is written that pop word off stack means from the stack you have to bring it out, and push means you have to push it onto the stack register. So that is how it will be saved onto the stack. Push and pop again, they are also same in your 8085 processors also. But how it is being used, that you can understand only when you are dealing with some program. But when you are discussing in your program control operations, you can simply say all these instructions are also included onto your branch instructions. They are also type of, sometimes what I have seen is they will give a question and they will give some 5 instructions and they will ask, explain all these instructions. So if you can get some old question papers, you will get an idea. They are asking to explain those instructions, how the instructions will work. So like this, in the 5 marks questions, if they are asking 5 instructions means each instruction will carry one mark. That is also there. So what my advice is, at least you be familiar with 8085 instructions and those which are common there and here, that you can follow the same explanation for them. That is what I feel. Now another one more, branch instructions also same I told. Now string handling instructions. This I have not put. You can see the material which string means it is a group of words. So you know in C language also you will come across this string, group of words. So that is a string. This is a special feature for your 8086. One full block of data can be moved from one position to another position. So generally block of data means it is moved from one memory location to another memory location. Now memory, suppose you are having five 8-bit data, let us say. You are moving from memory location address 2000H to 2004H. If you have to move that whole 5 data in different memory location to 3000H to 3004H. So that will form a string of data which is moved from 2000 to 2004H to 3000 to 3004H. So you see, you are moving that complete block, that is 5 bytes from one memory location to another memory location. So that is how, where you are using the string handling instructions. So in this string handling instructions, it is possible to simply move, or it is possible to compare, or it is possible to scan, or it is possible to load, or it is possible to store. So for each of these, simply if you are moving, you will say MOVS. See your material which is given to you. In that you can see MOVS will move this string. And in this, when you are moving this string, you see the direction flag will decide the direction of data flow. Means whether the movement is taking place from top to bottom or from bottom to bottom to top. Means what will happen in this case? If you are moving from top to bottom, then your address location will get incremented. If you are moving from bottom to top, means your address locations will be decremented. So that is where the direction flag will be affected when you are moving this string of data. So you can check your direction flag in that. In the direction flag, when it is 1, it is auto decrement, and when it is 0, it is auto increment. Auto means directly the flag will change the state, and if your memory location is incrementing or decrementing. So that is how the direction flag will be affected when you are moving a string of data. And then compare string byte or word. Two elements in the same string or different strings can be compared. So string means I said group of words or a group of data in a byte. Means 5 different bytes can be compared. So you can compare within the string or between the elements of different string. Now when I'm saying, let us say 5, 4, 3, 2, 1. These are all my different 8-bit data. 5 I am writing in one location, 4 I am writing in another location, 3 I am writing. So I can compare between 5 and 3 of one string, or I can compare this 5 with another element of another string. Here 5, 4, 3, 2, 1, we call them as elements of a string. Just as we say MSc second year class, means there are different people with different names. Each becomes an element there. So similarly in this string, how many different numbers are there? Each number is, this is a way of calling the data in that string as element. You call them as element. Just as in the class you call each one as a student. That is how you call them. So now next one in this, it is possible to scan, it is possible to load, it is also possible to store the string byte or string word. from AL or AX into a string memory. So it is possible to store from the register also into a string memory. So all these things you have to include when you are writing about the string handling instruction. Write the syntax for it and explain what work it is doing. Next one more is your process control instructions. So So in this now, there are 6 different types of instructions, no? So we have seen data transfer, arithmetic logic, program control, string manipulation. Now process control instructions. These are nothing but they will affect the flags, process control. It is given the name or I think, did you come across this word bit manipulation? Was it there in 8085? Each bit will be, whenever you perform arithmetic or logical operations, then the flags are affected. So in that, the how the flags are affected, or you can change the state of the flag using the process control instructions. So if you want to clear the carry flag, then you have to use instruction CLC. It will clear the carry flag. Similarly, if you want to set the carry flag, then you have to use instruction STC. So the flags can be manipulated or it can be changed using these instructions. It is not necessary that the complete flag register you have to change. You can only change one particular bit of that flag register. So that is the advantage of this processor control instructions. I hope it is clear. Instead of changing the complete flag register, we want to change only one flag. So in that situation, you have to use processor control instructions. So see there, if you can see the material which you are having with you, clear carry flag, set carry flag, means only one bit will be changed in that flag register. Now complement carry flag. So whatever it is there, if it is 1, it will become 0. If it is 0, it will become 1. So that is how the complement carry flag will work. Now clear direction flag. So if you have used the string operation, means direction flag may be 1 or 0. So you can clear it directly by giving CLD. Set direction flag is also there. Set interrupt enable flag, clear interrupt enable flag, halt until interrupt or reset. NOP is no operation. So processor control, it is working with carry flag, direction flag, interrupt flag, and then halt until interrupt or reset, no operation. Then lock is also one of the instructions, and then escape. When we are using cell phones or our computer, it is very easy to press the escape button so that we can go back again. But here you are having an instruction only as escape, escape to external processor. So one processor, when it is connected to another processor, then it is possible that the main processor you can avoid and then go back to your external processor. So that is where you are using the escape instructions. Then lock bus during next instruction. So this feature you can see, I think, when you are using the pin diagram also. So this is all about your instruction set. So if you are getting familiar with 8086 processor, with what all I said, very easily you can get some 20 to 30 marks out of your total marks. Topics are less only. Only thing is you have to get yourself familiar with those things. So since it represents one complete block, I think 8086 processor is one block in your syllabus, no?
Yes, ma'am.
Block 6 it is. So it will cover 20 to 30 marks if you are familiar with this 8086 processor. So this is all which I have to tell you for today. If you are having any doubts, you can ask.
Ma'am,
Huh.
in our textbook, page number 252,
Huh.
in the short answer question, second one, there is a REP label prefix there. And then
REP. REP, we have not come in across that instruction, no?
right. They ask in
Yes,
assignment
yes,
also.
yes. Actually, I think it should be RET, I think. RET it should be. It is mistake there. See, RET label is there. Just now I told, no?
RET.
Label. It is a branch instruction. Wait, I will come back to that.
Yes, ma'am.
So it should be RET label.
RET prefix.
See, in the screen also you can see RET. That is a printing mistake there.
Okay, ma'am.
So person who has given has copied with the mistake only.
In assignment, they ask same also.
See, you can tell, you can write there in the assignment also that the syntax given is wrong. It should be RET label. You can tell that. Maybe they may have given questions from your material only. That is why REP is not there. RET label should be there. They in your syllabus they have not said like programming, but in the essay type question they have asked a program to multiply two 16-bit numbers and store 32-bit result.
Page number 251 they already gave na assembly language
Yes,
program.
they have given, but then you have to understand and practice then these programs. And I think in the whole question paper you will get only one program. I am thinking, I am guessing that. But unless you see the last year question papers, you will not get an idea. I am thinking they will give only one program, either in 8085 or 8086.
From last 2 years, they ask smallest or largest number of.
Okay. In that JC, JNC, smallest or largest, that one, I think I discussed that in class also. I told one and I said if the largest number will be there, then instead of JC, you have to write JNC there. Same program only, but only one instruction will change between those two.
Yes.
Because the condition there will change. When you are saying jump on carry, jump if no carry, the flags will be affected. The flags, how they will be affected is whether A is greater than B or A is less than B. You will store one number in one register and you will be comparing the other numbers. First you compare, suppose there are three numbers. First you will check first two numbers. Let us say A is having one and B is having another number, and then you will always keep the smaller number in the accumulator. Then out of the two, which is smaller will be in accumulator. Then again that smaller number is compared with the third number, and again between those two, which is smaller, will be stored in the accumulator. So like this, you will be able to know which is the smallest number among all the three. So there the flags are affected. So you will be checking the flags and then saving the smallest number in the accumulator. And then finally the smallest number is in accumulator. You will say STA, store accumulator, to the address location, or you can directly check the contents of the accumulator. That is also possible. Okay, then with this my class is over for today. You also go through the things. So if you are having anything to ask, you can ask. Okay, then we'll again discuss tomorrow, right?